Hello everyone. So today in this video we are going to discuss about heavy duty transportation and clean energy transition. So every single day without thinking about it we depend on heavy duty transportation. The food we eat was carried by a truck we never saw. The phone in our pocket traveled thousands of kilometers before reaching us. The building around us exists because massive machines moved steel, cement, and material day and night. But behind this everyday convenience is something we rarely notice. Huge vehicles running non-stop, burning massive amount of fuel and producing a large share of global emission. Now imagine telling these vehicles to just plug in and charge like a mobile phone. That's where reality hits. Heavy duty transport doesn't stop for charging. Ports don't wait. Warehouses don't sleep. Supply chains don't pause. So the question isn't can we make transportation cleaner? The real question is how do we make the heaviest, hardest working vehicle clean without slowing the world down? And that's where hydrogen fuel cells enter the picture. In this video, we will explore what heavy duty transportation really means and why traditional electrification struggles here. And now, hydrogen fuel cells are already being used in real life, in trucks, ports, warehouses, and public transport. To keep the world moving while cutting emissions, this is not this isn't about the future of mobility. It's about the future of how the world runs every single day. So, heavy duty transportation refers to the movement of goods and people using large, high power vehicles which are designed for industrial and commercial use. These vehicles typically operate under demanding conditions, carrying very heavy payloads, running for long hours, and supporting critical supply chains such as food distribution, manufacturing, construction, energy, and public transport. Examples include long-haul freight trucks, port dredge vehicles, buses, mining trucks, construction equipment, and industrial material handling vehicles like forklift. Although heavy-duty vehicles represent a smaller portion of the total number of vehicles on the road, but they contribute a disproportionately large share of fuel consumptions and greenhouse gas emission due to their size, weight, and continuous operations. As government and industries push towards decarbonization, heavy duty transportation has become one of the most difficult sectors to transition away from diesel battery electric solution work well for cars and light duty vans. But they face serious challenges when scaled to heavy duty use, including excessive battery weight, long charging times, and grid limitations. This is where hydrogen fuel cells technology is gaining attention. Hydrogen fuel cells generate electricity on board by combining hydrogen with oxygen, producing only water and heat as byproducts. The electricity then powers an electric motor, delivering smooth, high torque performance similar to battery electric vehicles. The key advantage of hydrogen fuel cells in heavy duty transportation is that they combine the benefit of electric drivetrain with fast refueling and long range, which are critical for industrial operations. Instead of charging for hours, hydrogen vehicle can refuel in minutes, helping fleets maintain productivity and uptime. This presentation explore how hydrogen fuel cells are being used in real world heavy duty transportation scenarios, focusing on practical use cases rather than theoretical concepts. By understanding these applications, it becomes clear why hydrogen is viewed not as a replacement for batteries but as a complementary solution for the most demanding transportation needs. So, transportation is generally classified into light, medium, and heavy duty categories based on vehicle weight, power requirements, and operational use. Heavy duty transportation typically includes vehicle with a gross vehicle weight rating, which is called GVWR, above approximately 16 tons, though exact definitions vary by countries and regulation. What truly defines heavy duty transportation, however, is not just weight but the nature of the work being performed. Heavy duty vehicles are designed for high utilization, meaning they often operate daily across multiple shifts and under strict timing constraint where downtime is extremely costly. Common heavy duty transportation segments include long haul freight truck where class 8 tractor trailer move goods over hundred or even thousand of kilometers. Ports and container transport where truck shuttle cargo between ports, rail yards and warehouses, and public transportation system such as city and intercity buses that operate on fixed schedules throughput throughout the day. Construction and mining equipment also fall into this category as they require very high torque, durability, and reliability in harsh environment. Additionally, heavy duty transportation include industrial logistics operations within the warehouses and factories such as heavy forklift and yard tractors that move materials continuously. These vehicles differ fundamentally from passenger cars. In heavy duty applications, factors such as refueling time, payload capacity, reliability, and total cost of downtime are often more important than vehicle purchase price alone. A delay of even a few hours can disrupt entire supply chains. As a result, any alternative energy solution for heavy duty transportation must meet strict operational requirements. Hydrogen fuel cells are being explored precisely because they can meet these requirements in scenarios where batteries alone may struggle. Understanding what qualifies as heavy duty transportation helps clarify why hydrogen solutions are being targeted specifically at these segments. Moving forward, why heavy duty transportation is hard to electrify. So, electrifying heavy duty transportation is far more complex than electrifying passenger vehicles. One of the biggest challenges is energy demand. Heavy duty vehicles consume significantly more energy due to their mass, payload, and operating conditions. To meet these energy needs, using batteries alone is extremely large battery packs are required, and these batteries add substantial weight, which directly reduces the amount of cargo a vehicle can carry. So it will negatively impacting revenue for fleet operators. Charging time is another major barrier. Even with the high power fast chargers, recharging large battery pack can take hours. In heavy duty logistics, vehicles are assets that are expected to be on the road or in operation for as much time as possible. Long charging breaks reduces utilization rate and it can require fleet to purchase additional vehicle to maintain the same level of service. This significantly increase capital cost. Furthermore, many heavy duty routes such as highways, ports, mines or remote industrial sites lack the electrical infrastructure which are needed to support megawatt scale charging. Grid constants also play a role, supplying enough electricity for large fleets of battery electric heavy duty vehicles require costly grid upgrades, new substations, and long approval timelines. In contrast, liquid or gaseous fuels are easier to store and distribute at scale. These challenges do not mean batteries have no role in heavy duty transportation, but they do limit their practicality in certain use cases. Hydrogen fuel cells help address these issues by separating energy storage from the electric drivetrain, enabling fast refueling, longer range, and consistent performance without excessive vehicle weight. Now, hydrogen fuel cells. How exactly this technology work? Because this is the main idea, like how we are going to reduce the carbon footprint from this heavy duty vehicles. So a hydrogen fuel cell is an electrochemical device that converts hydrogen gas into electricity without combustion. Inside the fuel cell, hydrogen molecules are split into protons and electrons. The electrons travel through an external circuit generating electricity, while the protons pass through a membrane to combine with oxygen from the air on the other side of the cell. The result of this reaction is electricity, heat, and water vapor as the only emission. In heavy duty vehicles, the electricity generated by the fuel cell powers an electric motor, often supported by a small battery or capacitor that smooths power delivery and captures regenerative braking energy. This configuration allows hydrogen fuel cell vehicles to deliver the same smooth acceleration, high torque, and low noise associated with electric vehicles. At the same time, they avoid the need for extremely large battery packs. Hydrogen is stored on board in high pressure tanks and it can be fueled or refueled relatively quickly, similar to diesel fueling. This makes fuel cells particularly attractive for applications where vehicle must return to service quickly after refueling. From an operational perspective, fuel cell vehicles behave much like any conventional electric vehicles, but with refueling pattern closer to traditional combustion vehicles. This combination of electric performance and fast energy replenishment is what makes hydrogen fuel cell a compelling option for heavy duty transportation use cases. Okay, so moving forward, we will see real world use cases, long haul freight trucks. So long haul freight truck is one of the most prominent real world use cases for hydrogen fuel cells. These trucks often classified as class 8 vehicles and are responsible for moving goods over long distances between cities, ports and industrial centers. They typically operate under tight schedules and must maximize daily driving time to remain profitable. In this context, long charging times associated with large battery electric trucks can be a serious disadvantage. Hydrogen fuel cell trucks address this challenge by enabling fast refueling, often in under 20 minutes, allowing driver to get back on the road quickly. Because hydrogen has a high energy to weight ratio, fuel cell trucks can achieve long driving ranges without sacrificing payload capacity. This is especially important for logistics companies that are paid based on the amount of cargo delivered. Several manufacturers and logistic operators they are already deploying hydrogen trucks in pilot and early commercial programs. These trucks are commonly used on fixed routes or freight corridors where hydrogen fueling infrastructure can be centralized. Real world testing has shown that fuel cell trucks can match diesel truck in range and refueling time while eliminating tailpipe emissions. This makes hydrogen an attractive solution for decarbonizing long haul freight without disrupting existing operational models. So another use case we have like ports and dredge operations. So ports and dredge operations represent another strong real world application for hydrogen fuel cells. Dredge trucks move shipping container between ports, rail yards, and nearby warehouses. These routes are typically short in distance but extremely demanding in terms of stop and go driving, idling, and daily utilization. Because ports are often located near dense urban areas, diesel emissions from dredge trucks have significant local air quality impact. Hydrogen fuel cell trucks are well suited to this environment. They produce zero tailpipe emissions, improving air quality for port workers and nearby communities. At the same time, fast refueling allows these trucks to operate continuously throughout the day without long breaks. Ports are also ideal location for hydrogen deployment because fueling infrastructure can be centralized, serving many vehicles from a single location. Real-world port projects have demonstrated that hydrogen trucks can perform the same task as diesel dredge trucks while significantly reducing noise and emissions. These projects are often supported by government incentives and public-private partnership, making ports a key entry point for scaling hydrogen and heavy-duty transportation. Another use case is warehouse and industrial forklift. One of the most mature and commercially successful application of hydrogen fuel cell is in warehousing and industrial material handling. Large distribution center and manufacturing plants they rely on forklift and other vehicles that operate across multiple shifts, often 24 hours a day. Traditional battery powered forklift require long charging time or battery swapping, which can create downtime and require dedicated charging rooms. Hydrogen fuel cell forklift solve these problems by enabling refueling in just a few minutes. This allows forklift to stay in service continuously, increasing throughput and productivity. Fuel cell forklift also provide consistent power throughout a shift, unlike batteries that gradually lose voltage as they discharge. This consistency improves operational efficiency and operator experience. Many large warehouses and logistic companies they already use hydrogen forklift at scale, supported by on-site hydrogen production or delivery. In these environments, hydrogen has proven to be a practical, reliable solution that delivers clear operational benefits beyond emission reduction. This real-world success has helped build confidence in hydrogen technology for other heavy-duty transportation applications. Then buses and public transportation. Hydrogen fuel cells are also being used in buses and public transportation system, particularly for long routes, high passenger loads, and regions where limited electrical grid capacity. So, public buses often operate on fixed schedules and they must remain in service throughout the day. Long charging time can reduce fleet availability and require additional vehicle to maintain service levels. Hydrogen buses can be refueled quickly, allowing transit agencies to operate them much like diesel buses while achieving zero tailpipe emissions. The quiet operations of fuel cell buses also reduce noise pollution, improving passenger comfort and urban environments. In colder or hotter climates, fuel cells can offer more predictable range than batteries, which can be affected by temperature extreme. Cities around the world are deploying hydrogen buses as part of their clean transportation strategies, often alongside battery electric buses. This mixed approach allows transit agencies to match the right technology to the right route, using hydrogen where fast refueling and long range are most valuable. Now we will see hydrogen versus battery, choosing the right tool. So hydrogen fuel cells and battery electric system, they are often compared as competing technology. But in heavy duty transportation, they are better understood as complementary solution. Battery electric vehicles are highly energy efficient and work well for short distance, predictable routes where vehicles can charge overnight or during long breaks. They are particularly effective in urban delivery and light duty applications. Hydrogen fuel cells, on the other hand, they excel in scenarios that demand long range, fast refueling, high utilization, and minimal downtime. These characteristics align closely with many heavy duty transportation use cases. From an operational perspective, hydrogen allows fleet to maintain existing workflow while transitioning away from the diesel. Industry consensus is increasingly moving toward a multi-technology approach where batteries and hydrogen are deployed side by side depending on operational needs. This pragmatic strategy recognizes that no single technology can efficiently serve as transportation segments, for all transportation segments. Understanding the strength and limitations of each helps decision makers deploy clean energy solution more effectively. So to conclude this, why hydrogen matters for heavy duty transportation? Heavy duty transportation is one of the most challenging sectors to decarbonize due to its high energy demands, strict operational requirements, and economic sensitivity to downtime. Hydrogen fuel cells offer a practical solution for many of these challenges by combining electric performance with fast refueling and long range. Real world deployment in trucking, ports, warehouses, and public transportation demonstrate that hydrogen is not just a future concept but an emerging industrial tool. Rather than replacing batteries, hydrogen complements them by serving the most demanding application where batteries face physical or operational limits. As hydrogen infrastructure continues to expand and cost decline, fuel cell technology is likely to play a critical role in enabling zero emission heavy duty transportation at scale. Understanding these real world use cases helps clarify why hydrogen is attracting growing interest from government, manufacturers, and logistic operators worldwide. So this was all about uh, heavy duty transportation system and how this hydrogen fuel is going to I will say help in this particular sector to reduce the carbon footprints. So hope you like this video, and we will see in next video with some other interesting topic. Till then, goodbye, have a great day, thank you.